So here's another hypothetical example. Let's suppose, for sake of argument, that I have data from combination A, combination B, combination C, and combination ABC, that is 4 out of 8 combinations from a 2 to the 3 factorial. And let's suppose, for sake of argument, the sample sizes are 1, 2, 1, and 3. What am I talking about doing here? Well, in the first place, we're going to do an analysis ignoring the existence of factor C. So I'm going to act as if I have 4 y bars here that come from 4 combinations of A and B. First of all, I need to run the Yates algorithm. That means I've got to write things down in an appropriate order. So in this table, I have written down the combinations of A, B, and C in Yates standard order, ignoring factor C. That is, look at this first row here. As regards A and B, that's what? That's A low, B low, happens to be C high, but I'm ignoring factor C. That is both A and B low. That would be the first row in a Yates table if I had only factors A and B. As regards A and B, this is A high, B low. This is B high, A low. Those are the combinations that would be on the second and third rows of the Yates table. And now look at this last row. That is, as regards factors A and B, that's both A and B high. That would be in the last row of the Yates table if I was only considering the first 2 factors and not the last factor C. So the point is that this is Yates standard order as regards the first 2 factors. What am I going to do? Well, I'm going to do the Yates algorithm now 2 cycles, because I'm, after all, ignoring factor C for the first part of this analysis. So I'll run the Yates algorithm, the 2-cycle Yates algorithm. I make confidence intervals then for what comes out of the Yates algorithm based on a pooled S. Where does the pooled S come from? Well, I'm going to I have 4 samples represented up here, 2 of which have more than one data point in them, and all I'm going to do is take sample size minus 1 times S squared, sample size minus 1 times S squared, and add up sample sizes minus 1, and that'll get me a pooled S squared that I can use to make margins of error based on confidence limits. What does that do? Well, I've got 3 degrees of freedom for a T. I've got a pooled S. These things come from the Yates algorithm, and I've got a 1 over 2 to the something here. It's not 1 over 2 cubed because I'm doing an analysis temporarily ignoring the last factor, and then underneath the square root here I've got the sum of the reciprocal sample sizes for the half fraction that I have data from. And so I would judge statistical detectability of the things that come out of the Yates algorithm using this as my margin of error for things from Yates